Hey, good night, everyone. Welcome to the Daily Nightly Show. I'm your host, John Oliver, and again we have Dr. Wolf on the show today. Dr. Wolf, how are you today?
We're there.
We're there. Well, we're happy to have you again. If you just want to crack right into it, we're happy to listen.
All right, thank you. So today we're going to talk about registers and tri-state buffers. So in this course, we have so far talked about D flip-flops and other types of memory units. Some of them are flips, some are flops. But the main difference between a register and a D flip-flop is there is an enable bit in order to write to the register. So what do I mean by that? Well, let's just look in the book where it gives us code. So if we look at this, upon an always block, upon a pause edge of a clock, much like the D flip-flop, if L, which is our enable bit, Q will go to R. And so R is our input bit, and then Q is our output bit. And so if we wanted to include a reset like we did in the D flip-flops for lab 4, we could just have another if reset, then Q goes to 0. Yeah, so what you need to understand about what a register is it is basically a D flip-flop with an enable bit. The enable allows if the enable is high, a 1, then the bit can get set. If it's not a 1, then Q remains what it was before. The other thing we need to talk about are tri-state buffers, and if you want to know more information about them, I believe Dr. Kala has a video about it. But the difference between a register and a tri-state buffer is that a tri-state buffer will either allow a value through or not. And so that doesn't mean it's preserving the value of the bit like a register does. It just means it's allowing a signal to go through. So if we look at this assign statement, what this is saying is if E is a 1, if it's true, then Y. So that means that if E was high, if our enable was high, then Y, our input, will become our output, meaning it will just be allowed through. E, if it's false, or if it's a 0, then BZ is F, which means it's a high impedance bit. And so that basically, if you want to think of it like in Model Sim outputs a red or a blue wire. The red wire is unknown, and blue is high impedance. The main reason that we call this a tri-state buffer is because of the 3 wires that are connected to it. So tri, 3, So it has 2 inputs. One input is the like a bus wire, or just a number of bits like Y, where it can be 4 bits or whatever. And F would also be 4 bits. And so in our scenario, we are using 4 bits. That's why I keep saying that. So as a 4-bit input, and it would have a 4-bit output with a 1-bit enable. And so the enable will just allow it to go through or not. And so, yep, that's all I have today.
Well, Dr. Wolf, we appreciate you being on once again, and we hope to see you next week on the weekly Daily Nightly Show.
I'm looking forward to it.